So here I have a program ready to go. It's going to generate 10 random numbers. And when I hit the play button, I want you to just see that I do have 10 random numbers when they show up. They're going to take their time. It's early in the morning. There we go. So you see we're going to get random numbers in random order. We want to sort these random numbers. So our sort code for the selection sort, once again, goes like this. We first have our for loop, which is integer I equals 0. I is going to run until our array's name is numbers. So numbers dot length minus 1. Then I is going to increase by 1 each time, so we sort each area. This is where using your end comments will come in really handy because it will help you out a lot. Then we're going to look at the current I position. So we're working with integers. So integer current min equals numbers of I. And our current min index, which will also be an integer, will always be an integer, equals I. And then we're going to use that J loop, what we talked about, to search through to see where it belongs in position. So for int J equals I plus 1, because it'll move in relation to I, J now is officially less than numbers.length, so it guarantees that it gets its last position, J++. This ends J loop. Inside the J loop is where we create that first if statement to see if the current min is greater than whatever J is, to keep the piece moving down the line. So if current min is greater than numbers of J, and here we're going to end our if, and these two are close together. Yes, they are. Then the current min then equals numbers of J, and this again will search the entire rest of the array, and the current min index equals J. And as you know, but if you've watched all my videos by now, I can't spell. Come out of the J loop, what means our search is complete. In the event we need to perform a swap, if the current min index does not equal I, so it still has to be inside of the I loop, so it has something to compare to, then numbers of the current min index equals numbers of I. So it's moving first that last the bigger piece to where it belongs, and then it's taking the piece that was there and moving it to its appropriate spot down to the left. And this here also ends our if. Once I set this up, I'm going to go ahead and grab my for each print loop that I have set up here. I'm going to insert a blank print line just to give me some space. And then this should print out the after sorting. So let's take a look at how it looks. So before sorting, you can see like there's a number 4, ends up on the end, 12 and 12. 12 actually didn't move, so that's kind of cool. 21 only moved a little bit. 36 had quite a journey. 89 had to get all the way down here. So you can see it's very effective. It's very short, sweet, to the point. The best way I would recommend if you need to perform multiple sorts is to simply place it in a method and then just keep calling to that method, passing the array down. That will save you a lot of time, especially on our more complex programs. That's how you use the selection sort. And the next one that we're going to go over is insertion sort.